Welcome to eDay6. Today we're going to be writing equations of hyperbolas. First thing I would like you to do is pause this video and complete the warm-up. When you're done with the warm-up, come back and check your answers. Welcome back. Please pause this video, check your answers. Let me know if you do have any questions on graphing hyperbolas. Today's lesson, if you go to the next page, we're going to be writing equations of hyperbolas. First off, we should figure out where our center is. In this problem, our center is at 0, 0. The next important thing for a hyperbola is which one comes first. So with a hyperbola, we always have a minus sign, and it's going to be equal to 1. But is it going to be the x or the y that comes first? Notice this one opens up and down. Therefore, the y will come first. Because our center is at 0, 0, we can just leave it as y squared and x squared. The next thing we want to do is count how far we are from the center. So for our y, we have a distance of 1, and 1 squared is 1. For the x's, from the center, we have a distance of 1, 2, 3, 4, and 4 squared is 16. I'm going to ask you to pause this video and try the next one on your own, and then you can come back and check your answer. Our center is at 5, negative 2. And it opens left and right, and that implies that the x comes first. It'll be x minus 5 squared. Remember, a hyperbola has a minus sign, and then y plus 2 squared, putting in your center. Counting the distance from our center, 1, 2, 3, underneath the x would be 3 squared or 9. And if you count the y is a distance of 7, and 7 squared is 49. On the next problem, it says we have x or y-intercepts at plus or minus 3, and then it has asymptotes at plus or minus 3/4 x. First off, remember point slope. If we have y minus y1, then our slope, and then x minus x1. What's with the y and the x, that is our center. Because we don't have anything with it, we can tell that our center is at 0, 0. It also tells us that we have y-intercepts at plus or minus 3. If we have y-intercepts at plus or minus 3, that tells us our graph is opening up and down at 3. So if we begin, the first thing we're going to have is our y first because it's opening up and down. And our center is at 0, 0, so we will have just our y squared and our x squared. From here, we can count how far we are from the center. This is a total of 3 units, and 3 squared is 9. Now, how do we get the rest of the information? How do we find out what will go underneath the x? Well, they tell us what our slope is. And if we use our picture, I want you to almost think about it as a box that gets created. From our center, we know our rise is 3. And the question is, what is our run? And that it would be our distance for where those co-vertices would be on the x. So rise over run. I'm going to set it up rise over run. It tells us our slope in our equation is 3 over 4. And in our picture we drew, we know that the rise here is 3, and the run is what we're looking for. And you can see that how much we go over, our distance on the x, which can get transferred down over here, is a distance of 4. And then 4 squared is 16. The next one, 2 things that we can do to find our center. I think you may need to adjust your equation from on your piece of paper. Sorry about that. It looks like it looks like I want to adjust this problem. I was looking at what I had. Let's make this a 1/2 x minus 4. I think it'll make everything work out a lot nicer. So let's adjust this problem. Two things you can do is you could find your center of your problem from here. Our center, remember, x goes first, so taking the opposite, we'd have a center at 4, 3. They also tell us where our vertices are. So if you draw a little picture here, 1, 2, 3, 4, and we're up at 5, that's a vertice. And then we're at 4, 1 is another vertice. That's telling us that we're going to be moving up and down, and that our center is at 4, 3. If we're going up and down, that means our y is first, so you can get everything set up with your y first, and putting in the center. Our center will be, the 4 goes with the x, so minus 4, and then the 3 would be a minus 3. To find what would go with your y, underneath the y, if we were at 5 and we went to our center at 3, that's 2 units, and 2 squared is 4. And we're going to use our slope again to figure out our box, our rise over run. If we know we went up 2, the question is how much do we go over to the right? So rise over run. If we went up 2, how much did we go over? Well, we can look at our equation, and remember I changed it to 1/2. I made that so it was a little bit easier. If you prefer, you can always put this as your x, and when you cross multiply, you get your x to be 4. And then 4 squared is 16. The next one tells us we have x-intercepts. X-intercepts tell us that our graph is going to be opening left and right. And you'll be able to see that we are at the center, the origin, for our center. Our x is going to come first because it's opening left and right. And I'm just going to write x squared minus y squared because the center is at 0, 0. The distance from our center over to our x-intercept is 6 units, and 6 squared is 36. We are going to be using our foci formula. If you remember your foci formula, it's going to be c squared equals a squared. And then remember, it looks like Pythagorean theorem. Because our hyperbola equation has a minus sign, our foci equation will have a plus sign. And order does not matter when you are adding. We know our c value comes from our foci. So 3 root 6 is our c. So 3 root 6, and then we'll square that. And it doesn't matter who you write as a or b. Our 6 squared is 36, and then we'll solve for our other letter. When you square, 3 squared is 9, square root of 6 squared is 6, and that is 54. If we subtract over our 36, our b squared is 18. All right, flipping over to the next page. This next one tells us where our vertices are. And it says our vertices are at 8, 0 and negative 8, 0. That is along our x-axis. And that's going to imply that it's opening left and right, and the center is at 0, 0. If it is opening left and right, it's going to be the x coming first. And because it's at 0, 0 for our center, we can just write x squared minus y squared. The distance from here is 8, and 8 squared is 64. So underneath the x squared, we will put 64. Using our foci equation, we have c squared equals a squared plus b squared. They're telling us our foci is at 10. So that is our c value, the distance from our center to our foci. So we have 10 squared equals 64 plus b squared. 100 equals 64. And when you subtract 64, your b squared is 36. The next one is telling you where your vertices are. This one might be easiest to use a picture for. Or some people might like to look for their center using what coordinates are the same. So looking at this, I can find that my center is at 4, 5. Other people are going to prefer to actually draw a picture and get a visual for it. If we're at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, and 3, those are our vertices. That implies that it's going to be opening up and down. And then halfway between that would be at 5. So this would be at 4, 5. Starting off with that, remember it's opening up and down, so our y is going to come first. And remember to put the y coordinate of the center with it, and then x minus 4 squared. If we are at 5 and we're going to 7, that makes us a distance of 2. And 2 squared is 4. And then you can either plot your points. It would be at 14 and -6. And that would kind of create this box that we would have. It'd be a very long, narrow box. If we were to do that, we could count all those spaces, or you can think of the distance. If we take 14 minus a -6, that's a total distance of 20. But remember, your center going over is only going to be half of that, which would be a distance of 10. So half of 20 is 10. So cutting that in half, and then 10 squared is 100. Here they give you the vertices. This one you're kind of forced to draw a picture. You do know the x coordinate of the vertice, but you do need to find the y coordinate. If you are at 1, 2, 3, 4, 5, and then up at 19, and then 5, and then we're down at -1. If those are our vertices, what is halfway between? Well, this entire length is 19 minus -1 is 20 units. And if we want to find our center, which is halfway in between, we are going to be 10 points away. And that would land us right at 9. That means our center is at 5, 9. Our graph is going to be opening up and down. Because it opens up and down, the y will come first. Y minus the y coordinate, or the opposite of the y coordinates of the center, and then x minus 5 from the center. Looking at our picture then, we know that from 9 to 19 is going to be a total of 10 units, and 10 squared is 100. And they tell us our conjugate axis. If you remember, our vertices, I don't even know if I stressed this when we were graphing. I apologize if I didn't. They call this the transverse axis, is the one with the vertices on it, the direction that it opens, and the conjugate axis is the other one, the one that does not have them opening. So I apologize if I haven't used that vocabulary yet. It's kind of like the major and minor, if you want to think of it that way, but they use different vocabulary. So transverse are the one with the vertices, and that is the one, that would be this one's the transverse, going up and down, is the one with our hyperbola branches, and the other one would be our conjugate. So if they're saying our whole conjugate axis is 6 units long, remember from the center, we only want to use half of that, which would be 3 units. And then 3 squared is 9. All right, getting close here. They give us our center. They tell us where our vertex is, and then also where our focus is. If we were to draw a little sketch of this, it will tell us some information of how it's opening and our distances. So if we are at 9, and then down here at -7, I'm going to extend this a little bit, and then we have a focus at negative 17 and a vertex at negative 13. So remember that our vertex is where it's opening. Our center, and then it would open up here, our center is like halfway between the two branches. Because it's opening up and down, our y will come first. And then from here, we can put in the center. The center is at 9, negative 7. Now remember, the y is first, and opposite of a negative 7 is a positive 7. And then we have our x minus 9. To calculate our distances from our center to our vertice, if we're at negative 7 going to 13, that looks like it's going to be 6 units. And 6 squared is 36. They're giving us our information for our foci. That means we want to go ahead and get our foci equations set up. From our center to our foci goes from 7 to 17, which is a total of 10 units. And 10 squared is 100. We know our other one is 36, and then if we subtract 36, we get our missing one to be 64. One last problem to go. They tell us our center, and they say our transverse axis is 26 units long, and our conjugate axis is 14 units long. It tells us the direction of the horizontal. Remember, the transverse is the one that will have our vertices and our branches on it. And it's important that they tell us the direction that it's going. So if our transverse axis is horizontal, that means our graph is going to be opening left and right from our center. If it's opening left and right, our x will come first. So getting our equations set up. Putting in the center, we have x minus 10 and then y plus 3. When they give us the entire length of an axis, remember we have to cut it in half, because when we talk about the values of those a's and b's, it's from the center, not the entire distance. So 26 divided by 2 is 13, and 13 squared is 169. The conjugate is the other axis, the one that would help us when we're drawing kind of that box, but it does not have the vertices on it. 14 divided by 2 is 7, and 7 squared is 49. Tonight's homework should look very similar to this. You can follow along from the notes. It's writing equations. It is a one-page front and back. It is also located in your packet if you wanted to do in the paper packet versus the one posted on Notability. Great job today, and now you know how to graph both ellipses and hyperbolas. We have one more lesson of this unit left, and that's just naming the conic.